Hello everyone. So I did not find much reference material for the Godot VisualScriptYield function, so I thought I'll make a little video for it. So here I created a scene, and on the ready it's gonna load a few sprites, but let's just pretend it's a very long search function or something, or it's something asynchronous. You want it to update editor, so if you don't use yield, you'll just have to wait a few seconds, and then suddenly everything runs at the same time, and you can see they all instance at the same time because they're rotating at the same position. So for the yield, for everybody coming from GD script, you're gonna find yield and yield signal. I want to start with a disclaimer that this yield itself does not work. So I created my own build here of the engine. I tried to fix it, and yeah, so that's its own pull request now. Let's hope you get access to it quite quickly, and this is exactly the same as the basic coroutine explanation you find in the official documentations. So, and here on the right we have the timer timeout, which are basically the two pages you find if you go and look for the yield function in Godot. So what actually happens with yield? So this is the function that yields something. It's gonna stop execution right here, and it's gonna wait for something to happen, and it's gonna give everything else, all the other processes, time to update and do their own thing. So let's see what happens here. We have a print statement. It says hello. We're gonna yield it. We're gonna say, okay, let's get back to the original code. Let's finish everything else. Print my dear. Okay, let's see what happens here. Okay, on that function state that we got back from the yield, we're gonna call the function resume. That means we're gonna continue here, and we're gonna print world vs. So that's what you see here. We got a GD script version and a Visual Script version. We have 3 scenes we load, and we just have a simple timeout. So let's see what's happening here. We're gonna check the operating system time, and if it's far enough along, we're gonna allow it to spawn the sprite. So as you see here now, everything's running in load. Oops. Everything is running in load. Yeah, everything bottlenecks. Now we only have it 1 second, but let's say you're doing a massive iteration on the folders or something, or loading your perfect scene. It's gonna take a lot longer. It's gonna take a lot longer, and it's gonna bottleneck everything. So let's first start with telling you where the nice and easy yield functions are hidden. It's just called wait, and we got a wait frame, wait physics frame, and the wait time. So wait frame is very easy to give everything else time to just update. Frame's gonna update as many times as possible, and physics frame is set on a stable tick rate. So normally that is set to 60 frames a second. So that's So if you want it to run as many times as quickly as possible, just use next frame, next physics frame. Why would you want to use that? So if you do something with physics objects like raycast, if you just set them to a certain position and start a raycast, you have to wait an entire physics frame for the collisions to update. So that's when you want to use that. And let's just give on every time we run a little bit of code, the engine time to do its thing. And now you can see we have the instance running here from right to left, which is the bottom line, second line, first line. And the lines, well, they run in normal order, first line, second line and third line. So let's see what's going on here. We have our first code, it goes, runs, gets almost immediately a return. So in the first cycle we're gonna run the add text, print our first line. In the then we're going to continue to the second sequence port, so it's going to run another one single line of code. So the second line of code, then it allows the add text. Okay, let's continue once again. So basically everything here runs in a few frames. While we're waiting for the instancing to wait 1 second, half a second, almost immediately. So when you're using yield, your order of operations outside of it gets a little bit weird, but I hope I explained enough to it. I will link in below. I will send you a link of Amberus, who explains a good reason why you want to use it, and one will explain you how to actually use yield. But remember, the basic function actually does not work in VisualScript at the moment. So now that we have a normal running code here, let's see if we can delay it a little bit. So wait time is a really easy function. If you want to just have everything suspend, actually wait, it's properly named, for a few seconds. So let's say you start something, you shoot something, and you just want to give it half a second before you run the rest of the code. You do not have to start a new node, start a tree, and it's all controlled by the programmer, so there's no input here, it's just configuration. Let's see what happens. First line ran, we're waiting 4 seconds, and then the second line ran, starting the load process of half a second, and the third line ran, which runs a load process that goes really quickly. So that's that. And down here we have to wait on a signal, so yield signal, and it's, you can set it to just something. So let's see, a basic control node has all these signals. We can set it on a notepad, so if we have something in the tree we want to wait for, let's say something like line edit or something, we can say the label, and yeah, the label doesn't have an edit, of course. So let's say graphical UI input, we're gonna run it on that. or we can run it on an instance, which we are doing here because we're getting the scene tree to load a new timer. And on that, we're not just gonna do an object, we're gonna do a timer. And this timer, what signals does it have? It has timeout, hook it up, put it in between, and it's gonna run as you expected. I think that's it for the signals and yields. So I will leave you with a little time lapse of me creating this project, and have fun.